So hello everyone. Now we're going to be doing an inequality involving logarithms. Well, the basic rule for when you're doing these kinds of inequations is that if the base of the logarithm, 2 in this case, if the base is greater than 0, let's say that base is a. Okay, let's say we have a logarithm b to the power a, so b logarithm b with base a. So if a is greater than 1, then we'll just rewrite the same inequality sign because it's an ascending function then. And in the other case, if a is between 0 and 1, we just write the opposite inequality sign when solving these kinds of problems. Also, we have to set a condition, and that's usually just defining the domain. So we know that in order for a logarithm to be defined, its base must be positive and different than 1, and its numerous, namely this value here, or b, must be strictly greater than 0, at least in the real world. So let's go ahead and set both conditions. So 3x plus 4 is greater than 0, and when we take e to the power of these two sides, okay, not e, but 2, we have to put 2, the same number as the base. So we'll get that 2 to the power of log with base 2 of 3x plus 4 is greater than or equal to 2 to the 0 power. Okay, and this will give us that 3x plus 4 is greater than or equal to 1. Okay, so we have to solve both of these equations, which I'll mark in green, and find the values of x which satisfy both of them. So 3x plus 4 is greater than 0. That must mean that x is greater than negative 4 over 3, and from the second one, 3x plus 4 is greater than or equal to 1. So from here it follows that 3x is greater than or equal to negative 3. So from here it follows that x is greater than or equal to negative 1. So the final solutions will be easiest to find by drawing a number line. I'm just going to go ahead and use a ruler. Okay, so let's say that our 0 is here, so our negative 1 is here, which would make negative 4 over 3 be somewhere here. Okay, so in the first case, these are our values. I'm going to mark them in red. These values satisfy the first inequality, our condition, and these values right here satisfy our second condition, and that's including 1. So where we have both of these shaded areas, that's going to be our final set of solutions to this inequality. So, and that's including -1. So x goes from -1, including -1, and to positive infinity. Okay, so that's our final answer for this problem. I hope you enjoyed the video. If so, leave a thumbs up and subscribe. I'll see you in the next one.